Hi everybody, Mary here, and welcome to Chapter 2 on kinematics. And this is a little overview of the chapter. This is a long chapter. You're going to be on it for 2 complete weeks. And I want to give you a big picture of how the weeks are going to play out so that you can budget your time well. So let's go over to Canvas and look at what all you're going to have to get done. So this module 2 on kinematics is straight line motion. I really want you to think about this as a 2-week event. And we're going to start out, as we always do, with our notes that you can take a look at. Kinematics, we're going to talk about vectors, scalars. We're going to begin with some straight line motion, and then some example problems. A lot of definitions: displacement, velocity, speed, acceleration, and please do those example problems with me as we go through the notes. As always, we're going to have a study guide, and we're going to have a collection of homework problems that will be due for the entire chapter. I want to spend a minute talking about the schedule. Now, the schedule, you'll notice on the schedule that, of course, the dates will be different depending upon which semester you're taking this, but let's take a look at the weeks number right here. Kinematics Chapter 2 is going to cover 2 weeks, week 2 and week 3 of the semester. So if you look at week 2, at the end of week 2, here's what's going to be due: the graphing lab and the converting quiz, which is a leftover or a holdover from week 1. Now, you might say, hey, I don't have an awful lot to do this week. Well, yeah, but you have an awful lot of videos to watch and a lot of learning to do. So I want to show you kind of how far I would like to have you get in the videos, because at the end of week 3, you're going to have another lab, acceleration of gravity, a study guide that really covers 2 weeks worth of information, homework problems, which is a big batch of homework, and then a concepts quiz that covers chapters 1 and 2, and a problems test that covers 1 and 2. So please think of this as a 2-week exercise and plan your life and your time accordingly. When you go over to the homework problems for this chapter, as always, the homework problems are set out in bunches, and when you actually look at the homework problems themselves, I would like you to have as a goal for your homework problems that, remember, the example problems are in the beginning. Well, I guess, no, you don't remember. This is our first chapter doing this kind of homework problem. The example problems are in the beginning. These are the ones that I will be doing on video. And so you don't have to try and hustle and copy those down. Those are there for you. But the homework problems are done by bunches. So the first bunch is constant velocity and average speed. And then the second bunch is constant acceleration basic problems. Now, if you can get through that first collection of problems, or at least through number 12 or 13 at the end of the first week, you're going to be in great shakes, because there's a whole bunch of them. If you look to the very end, there's 19 complete problems, and they do get harder as the week unfolds. So if you can get through about 10 of them in the first week, you're going to be on a good pace. We'll talk about the lab again in a few minutes, but let's go to the very bottom and hit the next button. Yes, incidental background music. There you go. Okay, the next button. There are 2 labs this week, the graphing lab and an acceleration of gravity lab. The graphing lab is due at the end of the first week. Graphing is a skill that you're going to need for physics. And I am going to ask that you graph on Excel. Excel is a powerful part of the Microsoft Office suite. If you have Word, PowerPoint on your computer, you have Excel. You may not use it, but you have it. Within the graphing lab itself, there are instructions on how you can get this downloaded through CVTC if you would like to do that. But in the lab itself, you're going to do 2 things. One, we're going to talk about the difference between circumference and diameter, why it's pretty easy, and I want to use that as a vehicle to show you how to graph on Excel. And you're going to graph some constant velocity motion. You're going to do some scrounging around your home, and the scrounging around your home is going to be to find some, come on little doodle, there we go, is going to be to find some round objects. So I've given you some examples here. It doesn't matter so much what you've got, but you're going to need a variety of different diameters, some things with small diameters, some things with larger diameters. And I just went through my kitchen, my pantry, my closets to find everything from duct tape to plates to oatmeal. You're going to measure those diameters and circumferences and graph that information. We're also going to talk about reading to the correct number of significant figures. So that is part of what you're going to get up to. This part of the lab talks about, if you don't have Excel, how you can download that for free from the CVTC. And so follow that little set of instructions if you need that. If you do not, Yahoo, one less thing for you to do on your life. In the lab, I'm going to ask you to copy, paste, and insert a copy of your lab into your lab report. Now remember, your lab report is going to be uploaded in this lab format. If your labs end up a little bigger, you can adjust the size in your document. That is okay. But you must have a complete graph with all of the parts of a complete graph included. Remember, if you see things like this in any of the lab reports, those are grading notes for me so that I am fair as I distribute grades through the lab. Now, besides doing round things in circumference and diameter, one of the other things I'm going to have you do in this lab is I'm going to have you work with your little constant velocity car. This is the little car that you got in your box, and you're going to set it in motion. You're going to take some time and distance data with it. What are you going to use as your timer? You're going to use your phone. Most people have a stopwatch on their cell phone. So that's going to be your timing device. You're going to measure some displacements, do some calculations, find the slope using that Excel program, insert a couple graphs here. So this is an important lab regarding graphing. I highly recommend that you watch this video that I made on how to graph on Excel. This video pops up periodically inside of the course because I am aware of the fact that sometimes people have to learn something multiple times before that really sticks in. So graphing in Excel is a powerful physics tool, and that video will help you with that. If you get to the last section, 2-4, what we just got to, by the end of the first week of our 2-week section, you're in pretty good shape. For the second week of this 2 weeks on kinematics is all going to be on accelerated motion. So accelerated motion, this is objects that are changing their velocity, whole bunch of equations that you need to learn, a lot of mathematical problems, and then we're going to talk about the acceleration of gravity, what happens when an object is accelerated by Earth's gravity. Some wonderful, wonderful outside videos that I'd really like you to spend a couple minutes watching. We're going to do some problems up and down when objects are thrown up and they fall down under the influence of gravity. There's some hints and tricks about how to handle those problems. And when you're done with that, then you are going to be ready for the second lab, and this is due at the end of the second week, and this is the acceleration of gravity lab. So it's similar to the first lab in the fact that you're going to be doing some graphing, but please watch this video on graphical analysis of motion. It will really help you interpret what's going on in your lab. If you don't watch this, sincerely, you're going to have a tough time interpreting what's going on. And again, I have included that graphing on Excel. For that acceleration of gravity lab, again, you're going to need a lot of equipment from your lab kit itself. You're going to do a little bit more scavenger hunting of things around your home, but not so much. A lot of this is going to be equipment from your lab kit. You're going to need some books and things like that for lifts and levels. You're going to set up an inclined plane, measure some distances, mark these on your metal track, a permanent marker might be handy. You're going to use your stopwatch on your phone, time some motion of the steel ball down that track, graph that information, insert copies of multiple graphs into the lab, and hopefully come up with an experimental value for the acceleration of gravity. At the end of the entire module, you are going to find our very first problem test and concept quiz. Now, as I mentioned before, these are timed events. The concept quiz is 10 questions, 10 questions, and they're 3 points each. You have a short 15 minutes to do this. You do not have time to look up these questions, so you got to know your stuff going in. Make sure that you have done your study guide, you have all your information in front of you before you attack that quiz. The problems test is going to be 10 big math problems. They are 10 points each. You have 90 minutes. Again, time is part of that test, and so make sure you have all your equipment in front of you. The test has been designed so that you're going to have a variety of different problems. Some on straight line motion, some on accelerated motion. Some are going to be easier and some are going to be more difficult. So all of the problems are multiple choice. I am a little bit evil, and I'm just going to warn you that I'm a little bit evil. When I make up these test problems, I sometimes do them wrong on purpose, and those are sometimes the wrong answers that are given. So you have to know your stuff when you take these tests. So actually doing the homework, doing the labs, watching the videos are the key to doing a good job for the entire chapter. As things unfold, please holler if you have any questions. Best of luck. Kinematics is the heart and soul of physics. We're going to start this chapter. When are we going to finish using these equations? At the end of the semester. They go on and they perpetuate throughout the entire rest of the course. So have a good week or two, and we'll talk to you soon. Bye-bye.